the start of the sort of talk was really about the underlying sort of data structures and concepts of Git. Um, and then we kind of got to the point where we kind of use those data structures and that understanding to have a look at some of like the common operations. And unfortunately, we didn't get time to do that. So we'll go through in this talk like merging and rebasing and what's effectively happening kind of behind the scenes. So the sort of final slide that we got to was like a summary of these Git like concepts, and we'll just run through this. So the kind of idea is that Git is a content addressable file system. What this means is that when you're in your sort of working directory, like you have the content of the code that you're writing, right? Each file is like there, it's your like live view of the system. And what better way to check that you've stored the version of the file you're working on in a sort of persistence layer than actually to use the content itself. And then it's just like a set membership, like, is this file stored? So the nice way to do that is to use a digest of the file for the lookup key. And then essentially you can take a digest, which is lovely and fast, and is that digest stored in the back end? So then in order to, and we saw that in the .git objects directory, when you store a file in Git or add it in manually, that's where these things appear. Let me go to this stuff. Move Git deep dive demo. Copy. Override. Hold on 2 secs. What's it saying? Let's see. Override. Yes. Oh. Okay. Let's just copy the directory again. This will just set things up for later. Okay. So when we go into our .git objects folder, this is where we see these digests stored. The first 2 digits of the digest are the directory, and then when we go into these things, we see the actual content, which is the remaining 38 digits. And we see that Git also does some compression on the data. So how do you group the content? How do you group the content? We're talking about just the insides of the files, right? We're not talking about the file names. We're not talking about permissions on the file. We're just talking about the content. And we use tree objects for that. And a tree object, see if I've got a picture of one. We can probably look at a tree here. And this is what a tree object looks like. And if we contrast that to the actual file system, we have this idea that the subdirectories are basically more trees and actual content are blobs. And this tree data structure you see here, this file, this is where we introduce like the name of the file. You know, it basically links git.plumbing markdown document to this digest, and that digest is what we just saw in the objects in the Git folder. And then on this left-hand column here, we have the permissions. So we have this like idea of content. Then we have a tree object, which relates the content to a file name or subdirectory and introduces some permissions. That's the only kind of additional data that a tree object provides. So the thing about a tree object is that it's kind of a snapshot in time of, let me just go back to here. It's like a snapshot in time of your working directory. Like if I create another tree object and put some more files in, you know, and I just keep doing that. I just keep building up these like loads of different tree objects. And I can have various sort of snapshots of my working directory. So how you build up the tree object is something called the index or staging. That's the thing you manipulate and modify with your like git add command. So right now, have a look. How do you get status? I'm on master. So right now, basically, my like there's this kind of implicitness in that when you've got a nice clean repo like I have here, nothing to commit, that the index file basically means that the tree object data structure matches exactly the working directory. Right? There's like a one-to-one mapping. When I start to modify the working directory, we start to get a difference between the sort of index and the working directory, and that they're the changes that I'm working on and making. When I want to like persist and save my work, I add things into this index, basically start to build up further the tree structure. And then when I'm happy, I create a commit object. And what that does is that introduces more metadata, the things that you sort of typically want from a version control system, like who authored the changes, what time it was done. But more importantly, it has the relationship between one tree object and the previous. And this way, you kind of have this ordering of your snapshots over time. So the commit objects introduce an ordering of the tree objects, which are just snapshots of your working directory. So the ordering provides you with this like timeline, so you can go backwards and forwards and see what you were doing and when and why. Finally, on top of all of that, you have the refs. And that's because commit objects are kind of they're based on digests again, and they're kind of like difficult to work with for a human. So you basically have this ref object which points to the latest commit object you're working with. And when we saw in the previous video that branches are basically references to commits. And I think it might be helpful to kind of go through a quick picture. So we'll just run through this very fast. So here, this is our content, the string version 1. We build up a tree object and we say, well, first of all, we kind of create it in our working directory and call it test.txt. Then we say, okay, let's add that to our index. So basically we're adding a row into our tree, like over here, that says test.txt maps to the digest of this 83b8. And that's a snapshot of our file system at that point in time. And then when we commit the index, we're basically saying, you know, I did this, these are the reasons why, and that's our point in time. Then we do some further work. We introduce a new .txt file that has some new content. And we modify test.txt. We change it from version 1, the content of it, to version 2. So our index starts with the sort of contents here, and then it's modified now to have test.txt and utext point to these content versions. And then we write a second commit. So this second commit points to the first one to say, you know, this was the tree previously that was a snapshot of the working directory. And now the tree has pivoted over to this one. At this point, we also branch. We say, okay, let's have this like really easy human readable thing, basically a symbolic reference called test, and we're going to point it to this second commit. So this lets you do things like check out test. And what's going to happen is that when you check it out, test will look for the commit that it is referenced to. From that commit, it will go to the tree file, and then Git will make your working directory look exactly like the contents of the tree. Then the third thing we do here is we make some more changes. We have we've introduced a new subdirectory called back, which is just simply a pointer to the original tree, because we've kind of like reintroduced test.txt in a back directory. And here you can see some of the nice deduplication that Git afford for this idea of content addressable system, because this tree essentially looks like the previous tree with the addition of, as a pointer to, with the addition of a subdirectory with a pointer to this content. So we get some nice reuse. And here we've got the master branch, our like human readable kind of hook into how things are working. So if we checked out master, it would point to the commit, and Git would make the working directory look like this tree. Okay. Refs, friendly names. We won't go into tags. And also to note that in the sort of Git directory, there is a file called head, which is also a pointer, and that's to the sort of current reference you're actually working on, refs headmaster. All right, so that was a whistle-stop tour of all the stuff we went through last time. So we can have a look at some basic operations. I don't think this will take too long, so hopefully we can kind of get through this and get on with your day. So let's with the sort of everyday operations, what's actually happening. So let's have a look. So here we've got a picture of a fast forward merge. So let's have a look. What are we on? We're on branch master. Let's just see what branches we have. Main and master. Okay. So basically here we have created a branch called issue 53. So let's do that. Git branch issue 53. Let's switch to it. Right, and then let's make a commit on this branch, this C3 business here. So we're going to create a file called issue 53. Touch is just a units command to create an empty file. We'll add it into our index, and then we'll commit it with some work. All right, so if we look at the graph of this, we basically see here that master is C2 or FV8C, and we see that issue 3 is this work here. So then we jump back to master, and then we do some work. Let's do some work. We'll call it a hotfix file. We'll add it in, and we'll commit it. All right, then let's have a look at the graph of this. Okay, head, master, main. Right, so we've basically replicated what we've got in our little picture there. Let's see if we can do all. Let's clear it, and Do it again. So this is like a rotated 90-degree picture of this thing now. Okay. So what does a fast forward merge do? Well, this is well, let's do it. Let's do it. Git merge. So I'm on master. I'm going to do git merge. Oh, let's have a look. Hotfix. Not hostfix. Sorry, git merge issue 53. No, what am I doing? Hold on, got myself a little confused. Let's just clear this out. Git log graph all. Right. So right. I have not copied this exactly how it should be. So I will explain a little bit about how the ref log works a bit later if we get time. And I'm going to git reset 98E558E on branch method matter. Bear with me. Okay. Check out issue 53. Yeah. I got the just checking that I've got the commit. Okay. Check out what's that. Git branch. So there's another branch. So I actually did when I was trying to like build this up for you guys, I actually didn't create the hotfix branch. Oh man, I'm not having a good day here. So now we've got a hit. Now we've got a hotfix branch. I'm just going to delete this hotfix branch. Okay. So then we go into hotfix and we do some hotfix work. So let's touch hotfix. Let's add hotfix. Let's git commit hotfix. Git commit message hotfix. There we go. Right. Git log graph. Okay. So if you look here, right, I'm on my hotfix, and I'm pointing to this commit C4, which is actually 9897. Okay. And if we look at the git refs heads hotfix, it's this 9897, right? So this ref is pointing to this commit. So if we check out master and then we do a git log graph, we can see we were on a different commit here, right? 98E5. And if we do a git merge of our hotfix, you see it's a fast forward. And what has happened, all that has happened, yeah, is that we've just changed the reference. So if we look at the master reference and the hotfix reference, they're identical. There was absolutely no work that needed to be done. Like the data structures are such that we don't need to reconcile anything. All we need to do, because hotfix was subsequent work on the master line, is just change the reference that master points to, the commit object, to the new one. So this is why like fast forward merges are like really nice. Like essentially you have a clean set of changes. If there was like C2A, C2B, C2C, there's no need to like in between C2 and C4 right here. There is no need to like look at like other VCS systems. They might have to look at the differences and changes. You don't have to do anything like that. All you have to do is just update master to point to the new commit that hotfixes that. Remember, the commit points to the tree, and the tree represents the entirety of the snapshot of the working directory. So this is like a super nice, easy way of just saying, well, okay, let's get the hotfix in. We're sorted. And that you can see that happening here, like master and hotfix both now point to the same commit. And it doesn't matter how many commits are in between here, you can ignore those. You just need to update the reference. So that's all a fast forward is, which is kind of, really nice, right? A property of the system that just falls out really nicely. Okay. Let's have a look at a three-way merge. So let's have a look. I'm going to git reset on FE8C73 branch master git log graph. So yeah, no, I'll come on to that later. Right, so we're back to the beginning, back to sort of like none of the stuff I've done is now visible to us. Okay, so here we've got a three-way merge. So we've got a master branch, okay, and then we have our issue 53 branch as well. The master branch has some changes, and the issue 53 has some changes. So let's quickly kind of do that. So we'll branch off issue 53. Already exists. Let's just quickly delete it. We'll create it again. We'll check it out. And let's do some work. So we'll do touch one, basically create a file, git add one, git commit. Oh, we'll touch two, create a new file, we'll add it to the index, and we'll commit our new index. Okay, so now we have a branch with two changes on. And if we go to master, so check out master, and then we want to do just a simple change in master. So let's add, let's create a file called master change. Let's add it. Let's commit it. Okay, so hopefully get log graph and get log graph all. Let's just clear that. Let's minus the hotfix. Let's get rid of that. Okay, so we've got a master and we've got issue 53. And when you're looking at this, what you want to be looking for is we're going to do a three-way merge. We want this information and this information to be in the same code base, right? Again, you don't need to look at all the changes because we've got snapshots at points in time. What we want to do is we want to use a common ancestor and we want to use the latest point on the branch history. So when we come to look at this, we're basically going to use this commit and we're going to use this commit, the master change, and then we can go back in time to find a common one, this one, and then we'll use a three-way merging algorithm to reconcile the changes between the two. So we can't do a fast forward here because there is actually going to be the working directories are going to, it's going to be a new state, a state that's kind of not been seen before. So the nice thing is that we don't have to concern ourselves with the history. We just need to look at the latest point on the branch or the point at which you want to merge to. So if we git checkout master and then git merge our issue 53, merge branch. So this is no longer a fast forward. It can't just like magically move the reference for us. Make the changes, tells you what's happened. And then if we log it, we can see the common ancestor. We can see the changes in the issue 53 branch. And then this one and this one and this one have all been merged together to form this brand new one. So that's a three-way merge. How are we doing for time? I probably won't demo the rebasing because I want to get onto the resetting because that's pretty useful. But rebasing is another kind of strategy which is easy to understand. So what have we got here? We've got a master and the commit before we branched off and we made an experiment. So this here is a ref, a pointer to this commit C4, and this here is the master reference pointing to commit C3. So a little bit of work has been done since this branch was created. And a rebase, what that's actually what you're kind of saying, what we want to do is you want to go back to common commit, yeah, and instead of doing this like three-way merge and use the latest snapshots of these branches to form a new one, what you actually say is like, okay, now I want you to play back the changes in order. So when you rebase experiment onto master, you're saying, okay, go back to the latest point in time, the commit pointed to by C2. Look at the master changes, put those onto the experiment branch. So C2, like, so this change here, C3, if there was more, like C3 dash and C3 double dash, they would also get put on. Once you've finished putting those master commits on on top of the common answer, then start applying the changes that you've made on your branch. Yeah. Now these may or may not need work. So when you don't need work is when there's no sort of overlapping changes. So if this master work was on a completely different area, you're rebase, and that's like in typical day-to-day use, that's like 90% of the time. You can just happily rebase without having to do any kind of merge resolution. But if these changes in your experiment do clash with some of these changes that have been subsequently added to the master branch, then you will have to resolve those changes. But a rebase is essentially get the reference, well, work out the commit that was shared in the history, and then using the destination, replay those changes, and then replay your own branches changes on top of those, resolving if needed. Okay, so resetting. This is the stuff that helps you get out of a pickle. And you've seen me get into a pickle and then reset my way out of it. So let's just have a look at where I've actually left this. So I think I'm good right now. But I'm going to just tidy this up a little bit. I'm going to delete issue 53 branch. No. You know what? I'm just going to reset to FE88C. And then we do a picture. Okay, so let's have a look what resetting is. So this is the scenario. There's some content in file.txt, and it's v1. In fact, let's create this. So where are we? Git status, run master. Brilliant. So we'll do git add file.txt. No, let's create a file called file.txt. Let's add into it v1. Okay, and let's add that, and let's commit it. Okay, so we're kind of at this point here now. Let us then modify echo v2 into the file. Let's add it again. That's basically building up the index. Let's commit it. So now we've got to this stage, and let's just repeat it one more time. Okay. So there we go. We've got a file, and we've got versions of content of v3, v2, v1. Right. So there are three things we need to keep in mind: the working directory, our index, and our reference, our head. So at the moment, everything is kind of in sync. Our head represents our working directory. Our working directory has the latest version. And our head, our reference is the current one. So what happens if we do a git reset soft? So this notation at the end is basically saying reset to the commit just before the last one. So in this, it'll be this one here. I could type in 4E91. This is just some nice shorthand. So let's do that. So that's now done. What does our graph look like now? So we basically changed where head, our reference, points to. So we've basically said that the reference for master now points to this commit. Okay. So what does that what is that like? We've basically undone the commit. This is kind of what you see if you do a git commit amend. We've actually sort of said when we do a git commit and we create our object and we put our message in, we've gone back to just before that stage. So we've already our index, like you can see here, shows you that we've modified our file, right? And if we look at our file, we've got version 3 in. So this git reset soft, what it's done is essentially just move the reference for master back to the previous commit. It hasn't altered the index, which is what we use to build up our commit, and it hasn't altered the working directory. All it's done is sort of basically got rid of your commit. So I can just run git commit, I understand version 3, and it'll kind of put it back. And then we'll be back to our original situation, right? So this soft reset is essentially saying, right, let's keep our working directory the same. All the work we've done to build up our index, our tree object, all the changes in one commit, let's keep all that the same. But let's just sort of undo that commit that added in like the author and the reason why we did this work. And it just lets you sort of do that again. So that's kind of nice. So then the sort of next stage of reset. So let's have a quick look at where we're at. So we've got the next stage of reset is mixed. And this does exactly what we've just seen, but also now changes the index. So when we do a git status now, we see that our changes have not been staged. So this basically moved the reference to point back to the previous commit, essentially undoing the commit object creation and just on our timeline. And it also sort of reached into the index and put that back to what it was before. So this is like if you have never, you've done your work and you haven't even got around to doing a git add. And you can see that we can see that the file has got our content, all the stuff we've worked on our working directory. But if we wanted to sort of go back from this mixed head business, this mixed reset, we basically have to do the commit again this time. So we're going to say, we want to do this, and then we want to commit it again. So like this soft basically does one thing, change the reference. This mixed does two things. It changes the reference and undoes your index changes. And then the final one does three things. It actually undoes the reference change to the commit. It undoes the index changes, and it also puts the working directory changes on back to it removes those. So it looks at the commit here and says, okay, make the working directory match that commit. So let's have a look what that looks like. So just see where we are. So we've got our version 3 changes. Our file has version 3 in it. But now we're going to do a git reset part. And then we'll say head. So it's going to get rid of this. It's going to say, okay, head now points to this commit. It's going to undo the index changes, and it's going to put the working directory back to how it was. And when we look at this, we've got version 2 instead of version 3 inside our file. So a git reset hard is a good way to get to like a known state. So if you're ever in a point where you want to kind of delete your entire Git directory, you might want to do git reset hard origin master. And that'll basically put you back to how it looks like in GitHub. So what's happened to all this sort of, I've done this reset now. But there is all this content, like these file changes in file text. Like if you look at this graph, well, hold on, where is it there? it kind of chopped off that commit we did, right? And it's kind of left dangling. I mean, all the content is still actually there. We have actually put it into the persistence layer of Git, where we saw when we added all this content. And you might think, oh, we can't see it. But there is another log, and this is the Git ref log. And these are all the changes this is a log of all the changes you make to the references. And you can actually like reset to these things also. So even though, we're kind of at here and it looks like we've never made a commit, we have done some stuff in the past. And if you've kind of like feel like you've lost it, then you can kind of reach into this ref log, which is a log of all the changes to the references, and you can undo them. So here you see I moved head to the previous version of head, like head -1 or head +1. But if I actually was like, oh no, I shouldn't have done that, I really do want that commit and that work, I can do git reset hard and then this. Oh no, not that. I'll just type it. A6 AF.26. And then if I do my clear, it's back. So basically, the ref log can be a really great tool for, think of it almost like an undo chain. It lets you see exactly what operations you've done and undo them. So if a rebase goes horribly wrong, and you can't work out how to kind of manipulate the normal history into looking like it was, jump into the ref log, and then pick where you want to be. It takes a little bit of getting used to, but it's super useful for sort of jumping around. There's also a shortcut, like if I can also do git reset hard. I think it's original head. So if you do some sort of operation, and you can use the shortcut original head to sort of pop back to where you were. So that's now popped me back to the V2 version. And I could probably redo it again. And now it's popped me back to the V3 version. So that's a useful sort of get one to kind of remember. So when you're resetting, there's kind of 3 levels in summary. There's a soft, which basically does the references. There's a mixed, which does the reference and the indexed. And there's a hard, which does the reference, the index, and the working directory. And the reason why this one is kind of dangerous is because if you have stuff in your working directory that you have never added, then you're going to lose it if you do a reset hard. But if you're confident you've got something added at some point, you're kind of safe to do this and get your stuff back. So that's it, I think, for understanding some of the common operations with respect to commits and trees and working directories. Hopefully that is a little bit clearer on how Git works. Yeah.
Awesome, Matt. Yeah, thanks a lot for putting together all of these worked examples and going through it all interactively as well. And thanks for going off script and showing some error recovery scenarios as well.
Yeah, never good when you realize you've not created it properly.
But yeah, I know you shared those. I think you shared those slides last time, but if you could do that again in Slack, that would be really useful. There's a question in the chat from Rishikesh.
Okay.
Does the ref log also get synced when we push and pull to remote?
I don't know.
No, it doesn't.
It doesn't. Okay, that's handy to know.
I'm almost certain it doesn't, because it's a local thing, right? Like my ref log looks different to your ref log.
Yeah, yeah. There is some like there is some that yeah. There are some things out there that will push your local things into a shared repository. So I've worked in the past on these like horrendous Git flow code bases. And there's sometimes you have to or frequently you rebase or merge into branches like master that are a long way behind. And you just have to go through the pain of every time of doing these like three-way merges. And there's something called git re, and it lets you save your merge resolution changes, and then we'll attempt to apply those so that when you do these future rebases and merges onto your Git flow branch, whatever is going to be released, it can sort of autopilot you through them. And then there is the functionality to push those things to a central repo so that everyone can benefit from your merge resolutions. And then it gets very hairy and horrible.
I mean, there's
yeah,
always a context to everything, isn't there? But I think if you're in the situation of having to replay previous conflict resolution approaches, then like something's gone seriously wrong.
you've followed Git flow too much, and
yes,
yeah. But yeah, probably that. I don't think the ref log would make much sense because you spin around all the while, don't you? And I don't think there's any useful non-local info there, like Tom says.
Yeah, so essentially the thing that gets pushed to remote is kind of like a subset of the ref log almost, because like those are the parts of the ref log which actually got synced, or maybe not.
Well, I think when you pull down, you kind of pick a branch, right? And then when you pull down another branch from a central place, you basically create the reference locally that points to the commit in the Git base. So yeah, I don't think there would be. I don't know for sure, but
So git clone essentially starts your local ref log.
yeah, it feels like it would, but I don't know for sure. It probably populates it with the branches, and then it's up to you to go from there. Yeah, I think the important things to remember are that your merges are over the last commit in each of the branches you're merging over. Fast forward merges are simply repointers of references, and soft, medium, and hard on the reset, it translates to reference and commit, reference, commit, and working directory. And then you're pretty much going to be okay sorting stuff out. Of course, just use Magic on Emacs and you never have to worry about stuff ever. That's what I do.
There are now terminal interfaces which also mimic Magit like things. Like if you don't want to use Emacs but still want the Magit kind of flow.
Yeah. I've just started using IntelliJ at work, and they've replaced it with change sets or something. Oh God, it's so hard for me to pivot my mental model into whatever these things are. It's still using Git as well. I think Git has become so dominant now that it seems strange. Like even in Emacs, you've got this whole VCS layer that does things in an abstract way over all the previous version control systems that existed. And they shoehorn Git into that as well. And it just feels a bit clunky, I think. Yeah, any other questions?
I think I remember last time when I sort of gave a little introduction last time, I think I said that there probably wasn't a single JUXT team or project or whatever that was not using Git. And then afterwards, based on a discussion that was happening in the office, I realized that's not actually true, because Bank of America have integrated into Quartz. Their fundamental version control is still based on CVS. So it's not true that every single project and every single bit of code at Git at JUXT is actually now going into Git.
And that's why there was a lot of inertia when people switched from CVS to Git for people to naturally create branches. Because all a branch is, remember, is a reference to a commit. It's instantaneous to set up that sort of symbolic link. Whereas in CVS, that's not the model. There's an entire copy of the data, and everything gets cloned everywhere, and it's a central repo that everyone has to push and paste. I think that the decisions made by Linus were really strong. And I don't know if that's it seems, I was thinking about it. It seems very, if I was writing a version control system, I don't think I'd have done this, even though it looks so obvious and works so well. I'd have almost certainly gone down some algebraic diff DSL of the changes in files, right? Because they feel like the fundamental thing you want to work with. Yeah, you want to be close to the changes. You want sequence of patches. I feel like it would be the very natural way for me to do it, to pivot it and just say, you know what, this space doesn't matter. Let's just snapshot entire files, and not worry really about the changes, the diff. Let's delay all that calculation until when we actually need it. Do you think I would do that naturally? Maybe I would as I get older and better, but probably not. I'm not going to lie.
Yeah, I think there's a few rules of thumb, isn't there, as well, when working with branches. I don't know what other people think about this. I think it's always a good rule to, I don't really like Git flow as a concept. It sounds like you, Matt, were sort of referring to it slightly in a slightly disparaging way. I think for most projects, it's massively overcomplex, and even for those overcomplicated, and even for those projects that are using it, it's often it's based on an assumption of a need for a lot of complexity and release processes that actually isn't there. One rule of thumb that I think is good to have is that whatever you're releasing, whether it's in it's in a staging environment or a test, or if it's in production, it should always be a point on a common history, not something that you have created by cherry picking a different set of things into production, let's say, or a different set of things into a new branch. I always think it's a good rule of thumb to say, no, there should be, this, if we're putting something in production, it should be something that is on the same line, the same historical line as something that's gone into staging, something that's gone into dev, whatever.
Yeah, that's nice. I've worked the whole gamut now. I've worked, I mean, not so long ago, maybe 2 or 3 years, I worked at a place that considered banning branches, and everyone had to work on master, and everyone had to pair program, and your changes just needed to work. And tests were there to catch releases that shouldn't go out. And it was almost like I don't know. I understand. I think it was a ThoughtWorks thing. I think there's an article on it somewhere. But it is a pushback a little bit to this complexity of, these things are like pendulous, right? Branches are difficult and hard. No one used them. Then everyone overused them, and then there's a pushback to not using them so much, all the way to the point where like you're banned from using them. But I think that being able to have a branch and a central repository, like a GitHub type central location where reviews and auditing happen as a gatekeeper is a pretty nice model, personally.
Right, I need to drop off to another call. I'm sure a lot of people do, but yeah, thanks again for that, Matt. And if anyone wants to, I'm a little bit behind on uploading videos, but if anyone wants to like revisit part 1, I'll make sure I get that into Google Drive imminently. And yeah, like I say, thanks again, Matt, and we'll see everyone in 2 weeks' time.
Cool. Cheers, guys. Thank you.
Cheers.